Vanakkam. Welcome to this video on biomechanics. So far we have looked at biomechanics of the upper limb. We started out with shoulder, then we did elbow, wrist, fingers, then we did biomechanics of spine, then we did biomechanics of hip, then we discussed knee. In this video we will be continuing our discussion of the musculoskeletal system, the joints of the musculoskeletal system, and focus on the biomechanics of the ankle joint. So, in this video we will be discussing the anatomy of the ankle joint and the movements that are happening at the ankle joint. Technically there is only a movement that happens at the ankle joint. Some other movements that also happen within the foot happen not in the ankle joint, but happen within the foot. So, this is essentially only movement on the ankle joint and other movements that happen in the foot. Okay. Movements happening in foot. Okay. So, this is the talus, right. There are many parts to this bone, the big bone, that is the talus, that also appears as the ankle, visible joint, visible mark in the body, visible architectural or something that you can note within the body, right, the ankle joint, that is the talus. So, when you say ankle joint, you are essentially referring to the talocrural joint, which is a hinge joint. So, hinge joint means only 1 degree of freedom possible. That 1 degree of freedom that is allowed by the talocrural joint or the ankle joint is the flexion and extension, what would normally be called as flexion and extension of the ankle, but in this case called as dorsiflexion and plantar flexion of the foot, dorsiflexion of the ankle joint and plantar flexion of the ankle joint. It is not called as flexion and extension. Remember that in biology exception is the rule. We spoke about this. For example, when we spoke about that movement of the wrist, that movement at the wrist we called as radial deviation and that movement as ulnar deviation. It is not called abduction and adduction, it is called radial and ulnar deviation. We said this earlier. Likewise, you have dorsiflexion and plantar flexion, and this is the only movement, or these two are the only movements that are possible in the ankle joint. But below the talus there is the so called subtalar joint, and there are other joints that are present at the calcaneus bone, that is at the subtalar joint and between the talus and the calcaneus bones, and movements that are happening at the tarsal bones. All these bones allow for very small amounts of movements. They are not well articulated joints like the other joints that we have seen so far. They are not like elbow joint, they are not like shoulder joint, they are not like knee joint. They are plain joints. These are plain joints. Unlike the talocrural joint, which is the ankle joint, which is a hinge joint, these joints that we are speaking about, the joint between the talus and the calcaneus and the tarsal joints, are all plain joints. All these joints together produce a substantial amount of movement, but each of them produce a very small amount of movement in the plane that we are discussing. That plane joint movement is really small, but all of them add up to produce a relatively large, or what is a visible amount of movement. This is called as eversion and inversion. We will come back to that in a bit. Okay. So, those are the movements that are possible. So, this is the subtalar joint, right. That is a subtalar joint in the side view, the lateral view, right. See, articulations of the subtalar joint that are happening here, right. Those movements that you can perform, movements of the foot such that the toe moves towards the midline and the little toe moves away from the midline, all these are possible. An important part to discuss while discussing the ankle joint is the crucial role of the many ligaments that are present in the foot, because these ligaments, for example, the calcaneofibular ligament, the medial malleolus and the lateral malleolus, and all these ligaments together are responsible for the stability of the ankle joint and the foot. Some of them prevent excess eversion and some of them prevent excess inversion. Some of them are responsible for stability of the ankle joint itself. Right. So, this some of the also the deltoid ligament is shown here. So, this is one of the more ligamentous joints, obviously because it has the responsibility of passing on the entire load of the body onto the ground and not destabilize while doing so. So, it is having quite a few ligaments that are responsible for stabilizing all these joints. So, you want to have movements when you want to have movements, and you want to prevent unwanted movements. It is a very complicated exercise, a very complicated or very challenging exercise. Preventing unwanted movements or stabilizing is one of the crucial roles that is achieved by all these ligaments, but at the same time I want to move when I want to move. If there is no movement, then there is no purpose. So, you want to have movements. It turns out that this is the crucial aspect of movements that many people who are not from movement science fail to recognize. In movement science, there are two aspects to studying movements and to rehabilitating movements. One is having the movements that are desired. Two is preventing movements that are not desired. After this digression, let us continue with our discussion. So, we were discussing that the talocrural joint has only a single degree of freedom as a hinge joint, and the other movements that are happening at the calcaneo or between the calcaneus and the talus, the subtalar joint, and the other joints at the tarsals. Right. All these joints together produce these small movements that then combine, that then add up to produce the so called eversion and inversion of the foot. Right. This is what we have discussed. Now, let us look at the movements that happen at the foot. Right. When the ankle moves or when the foot moves such that the big toe or the toes of the foot are moving towards the front side of the shin, front side of the lower leg, or in other words towards the anterior side of the leg. So, such that this is where the foot is originally, and this is the leg. That distance or that angle is reduced, right. This is called as dorsiflexion. Okay. This is where the dorsal side of the foot flexes, which is why it is called as dorsiflexion. Now, if you move the foot such that your toe is moving down and your heel is raising up, like I am now doing, I am standing and I am doing that, such that it is almost like you are standing on the toes of your foot. You can try doing that, like the ballet dancers. It is almost like you are standing on the toes of your foot. The movement that happens at the ankle joint to do this action is called as plantar flexion. In this case, the angle between the leg or the anterior side of the leg and the toes will increase, right. This is called as plantar flexion. These are the only two movements that happen in the ankle joint or the talocrural joint. This is the only movements possible in the talocrural joint or the ankle joint. Now, other movements that happen through the addition or through the summation of the small movements that happen at the subtalar joint, at the other bones of the foot, cause inversion such that the big toe moves medially, or eversion such that the toes move more laterally. This is not moving the foot itself. This is not moving the whole foot. Okay, you can bend, slight bending of the foot towards a middle side, towards a medial side, or towards the lateral side, right. If that happens, it is called as inversion and eversion. Of course, I can rotate the entire leg, right. That is called as internal rotation and external rotation, but that is not happening at the foot. Suppose this hand is the foot, it is not like I can rotate the foot like this. I rotate the entire leg, along with that the foot also rotates, right. That is why that internal and external rotation is happening due to rotation at the hip joint. Remember, the hip joint is a ball and socket joint with 3 degrees of freedom, is it not? Something that we have seen while discussing the hip joint. So, it can also rotate. That rotation is what is visible at the foot. That does not mean that the foot is having one extra degree of freedom such that it can rotate whole, in the plane of the ground. That is not possible. I mean, the foot does rotate in the plane of the ground, but the rotation is not happening at the ankle joint, it is happening at the hip joint. Okay. So, in this video, we saw the anatomy of the ankle, we saw the movements that are possible in the ankle, we saw that the ankle is actually a hinge joint that is allowing only for 1 degree of freedom or only one movement, that is the plantar flexion and the dorsiflexion, and other movements such as inversion, eversion are happening due to movements at the other joints, for example calcaneus and the subtalar joint, and the internal external rotations are movements that are happening at the hip joint, but that may be visible, that may be manifested at the foot. So, with this we come to the end of this video. Thank you very much for your attention.